Hi YouTubers, welcome to one of my videos. I'm in the garage working on the frequency counter, frequency meter, and I've finished the box. It's a plastic box. I've used this copper stuff inside the box as screening. This will make electrical connections with the top when that's screwed on. I haven't made a very neat job of it, to be honest, but to be fair, I've got very little of this material left. This it's fiberglass or glass fiber strands coated in copper. It might be beryllium copper, I'm not sure. It's difficult to get hold of, and I should imagine it's going to be very expensive. Now, what's the case made out of? Well, very simply, it's plastic, and this is the material I use. Excuse the shadow, it's a bit difficult in here with the light. And this come from my dad. I think one of the companies he worked for, he bought a load, different sizes and thicknesses and things like that. And it's very lightweight, easy to glue, and I use silica quick, what's the word? It's quick setting glue, super glue, but the gel type, and it makes good boxes and things like that, and you can sand it and paint it and do all sorts with it. This odds and ends I've got left. I've got to make a power distribution panel with some of these bits. I've got a big sheet here, and you can see it's probably 1 metre by 1.5 meters, and then I've got some thinner stuff. This has got a plastic coating on to protect it from scratching. It's the sort of thing you put in a wet room, basically, and it's really good stuff to use. Really like it. Cut it with a wood saw. Can be cut with a circular saw or a hacksaw. It works a treat. Now then, back to the actual, not the case as such, but back to the modules. Talk about the modules. Now, the modules themselves, I've checked the specification, and the second module is the same size as the first module. And why am I fitting two? One's a high precision module on the frequency, has a frequency reference on it. This one I fitted, the 12 volt one, is you can program it so you can subtract or add the IF frequencies to it if need be, and they're going to be in the same box. One issue I've got is this module runs from 12 volt. The one I'm waiting to arrive runs from 9 volt. So I've got a 9 volt 709 voltage regulator to fit in here somehow, and what I'm thinking of doing is having a piece of angled metal along here and have the regulator standing up. Now, these modules draw less than 100 milliamp, so it doesn't need a real big heatsink or anything, but I'm going to use a 1 amp regulator, a 7809, which is, I think it's 12 to 20 in, or something like a 9 volt out up to 1.5 amps. I think it is anyway, so that's the idea. We'll make an L plate out of aluminium. Going to use the on-off switches to hold the aluminium in, and then I'll start on the wiring actually, because I really need to get on with this project. Now, I've removed the two switches, and this is the aluminium. It's very, very thin, and I'm going to put it in there, and then hopefully the regulator will mount on that and fit back in the case with a bit of luck. And then I need to sort out some wires and things like that for electrical connections. Okay, this is where the heatsink's going to be. It doesn't need a heatsink for the amount of power, but it's just an easy form of mounting. And this, I've just fitted a 78112 regulator. It's going to have a 7809 in there when I've finished, and this is just to give you an indication of what it's going to look like. And yeah, I think that's going to be okay. I've just got to sort out where the decoupling capacitors are going to go, and the leads will be bent at a different angle, and yeah, it's coming on. It's slow but sure, and as I say, I'm waiting on parts to arrive. Okay, that's roughly where the regulator is going to be, and there's the heatsink, which is not needed. Two decoupling capacitors, 47 microfarad and a 33 microfarad, I think it is, and two ceramic decoupling capacitors across it as well for any RF, and just really waiting for the other bits to arrive. I found a 12 volt power supply here. It's a switch mode one though, don't know whether it's going to be any good. At 12 volt, half an amp. I can't even remember what it's from, but it's left over from some other project. Excuse the poor lighting. I've now found a way to run both of these boards on 9 volt. This was supposed to be 12 volt, but there's a hack you can do, I'm not going to share it, where you can alter the board so it runs on 9 volt rather than 12. So I've not fitted the regulator, although I've left the heatsink there and the filter capacitors just in case. I put a PP3 battery clip on it. I've got it all wired. It does work. What I'm going to do now is very simply drill the top cover so that I can screw the top cover on. So I need some matching screws to match the ones I used over here. So I put that to one side, and I need to find a drill suitable to do this job. Okay, so that's it finished, and so on the left this is the frequency generator, and on the right we have the frequency meters, top one and the bottom one. The bottom one is more microprocessor controlled, the top one is to high frequency, it's to 1.1 gigs I'm told, and the bottom one is to 500 megahertz. Similar displays used on both of them, and there we can see the displays, just about read them. So that project's finished, and it's difficult to show it working because the camera doesn't seem to show the display very well. This one's not plugged in, this one runs from batteries, and I can use both of them. And why have I got 2 meters is very simple. They're not traceable lab standard frequency meters or frequency counters, but because I've got 2 of them, I can simply add the 2 frequencies together, if they're both reading dissimilar, divided by 2, and that will give me a more accurate reading of the frequency. Now I'm not sure, it's slightly off by a couple hundred hertz on each, but I don't know whether it's the meters or the frequency generator. But thanks for watching. Please subscribe and like. Thumbs up.